Imagine you're pitching $1 million contract, right? You hit present on your laptop, and the 80-inch boardroom screen just stays pitch black.
Oh, the absolute worst.
Yeah, it's a career-ending nightmare. But preventing that exact scenario is actually why a very specific, totally hidden industry exists. So welcome to today's deep dive. Our mission today is translating a pretty dense spec sheet for the Atlona AT-HDR-SW-52ED.
Right, the 5x2 HDMI Matrix Switcher.
Exactly. And it costs almost $1,500, which immediately makes me wonder, why is anyone spending that kind of money on a physical hardwired box when we have all these wireless casting options in 2026?
Well, mainly because wireless introduces latency. And, drop packets. High-end corporate AV environments simply cannot tolerate that. I mean, the Atlona isn't just duplicating a signal here.
Yeah, it's doing a lot more than that.
Yeah, it's a professional command center. It's handling immense, uncompressed data streams where absolute reliability is paramount.
Okay, so let's break down how it actually handles those streams, starting with that 5x2 matrix capability. I like to think of it not like a traffic cop that stops and starts cars, but more like a high-speed digital railway switchyard.
That is a great way to put it, yeah.
Right, like you have 5 continuous inputs, say multiple laptops or media players at a massive conference table, and the switcher continuously routes any of those data streams to 2 different outputs simultaneously without any collisions.
Exactly. But the real engineering feat here is actually the HDBaseT output. It's pushing 4K video at 60 Hz with 4.4.4 chroma sampling.
Meaning it's not compressing the color channels, right?
Right. Doesn't compress the color to save bandwidth. Like every single pixel keeps its original color data, but it's not just sending video. Over a standard HT6 cable, HDBaseT multiplexes that 4K video, plus multi-channel audio like Dolby Atmos, Ethernet data, and get this, up to 100 watts of electrical power.
Wait, hold on. Sending electrical power and high-speed data over the exact same twisted pair copper wire, doesn't that usually create, like, massive electromagnetic interference?
You would definitely think so, yeah.
So how is it doing all of that over a single cable up to 330 feet away without the video feed just turning into static?
Well, it uses this advanced signaling technology that basically separates the data and the power across different frequencies within the cable. It essentially carves out dedicated, shielded lanes for the high-frequency video and network data.
Oh, and then it runs the direct current power beneath it.
You got it. And the receiver at the other end, 330 feet away, just splits them back out perfectly.
Okay, wow. So we've got this massive pipe of data traveling longer than a football field. But what happens if you're cramming a massive 4K stream down that pipe and the display at the other end is, I don't know, just a legacy 1080p monitor?
Yeah, the classic mismatch problem.
Yeah, because doesn't forcing a downscale introduce noticeable latency? Or wait, does the whole system just drop the 4K displays down to 1080p so everything matches for everyone?
Actually, neither. And that's thanks to how it manages the EDID handshake. Extended display identification data is basically a digital ID card that the monitor sends back to the source.
Okay, so the Atlona is intercepting those ID cards.
Exactly. It reads, say, the 4K projector on output 1 and the 1080p monitor on output 2. So instead of forcing the source device to just output the lowest common denominator, the switcher's internal processor scales the video frame by frame.
Just for the 1080p screen?
Yep, independently, in milliseconds. So the 4K screen gets to keep its pristine signal.
Oh, that's wild. So it's actively negotiating the hardware limits in real time. That explains the signal routing. But the spec sheet also mentions it manages the hardware itself through automatic display control, like bypassing the need for a separate remote altogether.
Yeah, it completely automates the room.
But how is it physically waking up a projector just because you plugged a laptop in?
It relies on voltage detection on the HDMI pin itself. The very moment it detects active 5-volt power from a connected device, it sends a control signal. Usually, this is over RS-232 or CEC protocols, directly to the displays.
And that just triggers the power on sequence instantly.
Instantly. And when that voltage drops, because, you unplugged your laptop, it initiates the projector's cool-down cycle, which protects the hardware.
That is fascinating. Looking at this device, really highlights all that invisible infrastructure running modern presentation spaces for you. Like when you walk into a room, plug in a single cable, and a 4K presentation flawlessly fires up across multiple mismatched screens.
Yeah, it's definitely not magic.
No, it's because this highly specialized switch yard is doing all the real-time signaling, scaling, and voltage management behind the scenes.
Exactly. True plug-and-play simplicity for the end user actually requires incredibly complex active engineering on the back end.
Which really leaves you with a final thought to mull over. As our data demands only get larger and wireless spectrums get more and more crowded, will we ever actually outgrow the need for heavy-duty physical switchers like this, or are we permanently tethered to the absolute reliability of copper wire?
It's definitely something to consider next time you hit present.